Hello, my name is Professor Armoni, and in this short video I would like to tell PhD candidates about my research. So if you're interested in the things I'm going to say, please apply for a studentship in Swansea University to the physics department and to have a PhD with me. So let me tell you briefly about my research. My research is about the interplay between string theory and field theory, and mostly about the strong interaction. Why the strong interaction? The strong interaction is still a rather not well understood theory. So in the strong interaction with quarks and gluons, the quarks are attracted by the gluons and they form something we call bound states or color singlets, like the proton and the neutrons. So the proton is a bound state of two U quarks and one D quark, and the neutron is composed of U and two D quarks. And a great mystery is the question about confinement. How the strong force, how the gluons attract the quarks to form protons and neutrons. And my research is about string theory as a tool to answer these questions. So it turns out that in recent years that string theory is a very useful tool in order to tackle these questions about confinements and in general dynamics of the strong interaction. So let me mention just one tool which is part of my research, which is called holography. So the basic idea behind holography is that a quark and an antiquark are connected by an open string, and this is why they are confined. Now, the dynamics of these open strings can be described by a method called holography, by dynamics of actually closed strings. So this is an open string, and this is a closed string. In order to understand the dynamics of open strings, of the confining string, we use closed string theory. But the closed string theory is not our 3+1 dimensional world. The closed string theory is a 10-dimensional superstring theory. So the basic idea in holography is that there are closed strings that propagate in a 10-dimensional world, and the dynamics of the closed strings in this 10-dimensional world is captured on the surface of this manifold, and somehow, well, only 4-dimensional, 3 plus 1-dimensional part of this 10-dimensional space is relevant. So there is a duality, the word is duality. There is a duality between the dynamics of 4-dimensional field theory, quantum chromodynamics of quarks and gluons, and 10-dimensional string theory. And this duality is holography. The dynamics of closed strings in the bulk of the 10-dimensional world is dual or equivalent to the dynamics of QCD in 4 dimensions. So that's a very useful tool. In my research, I'm also studying other dualities, a duality called Seiberg duality, another duality called S duality. I use toy models in 3 dimensions and 2 dimensions. I focus on dynamics of non-supersymmetric theories rather than supersymmetric theories as most people do. So my specialty is dualities between non-supersymmetric theories. So you can read on my research either on my page, my homepage, and links on my page, or using the tool called Inspire. So let me encourage you to apply to a studentship under my supervision, and please don't hesitate to contact me via an email. My email address is a.armoni@swansea.ac.uk.